Good morning, class. I hope you have a great day today. Let's start this individual review. All right, so first thing I notice on number one is I'm going to go ahead and cancel out this y to the 0 and just not even worry about y because I know anything to the 0 power equals 1, and then when I multiply, it'll just disappear. So actually, the only thing I need to worry about is plugging in this 3. So I get 3 to the negative second, which we know actually means the reciprocal of that. If we think about that as like being 3 over 1, the reciprocal would be 1 over 3, and then it would be to the positive 2, and then 1 over 3 would be 1. 1 over 3 squared would be 1 over 9. Number two, I noticed that there's not any of the same variables, the same letters. So all I can do is, just like on the last problem, I'm just going to cross out that b to the 0. I'm not even going to need it anymore. And then I notice that a is to the negative 3, so that one can go to the bottom. C to the negative 4, that one can go to the top. So basically we have a flip-flop situation. Negative 2 is a regular number, so that baby's staying put right there, should not move. So then my final answer would be negative 2c to the 4th over a cubed. All right, number 3. All right, this is just a straightforward distributing the exponent, but we got to remember that y has a 1 there. So I multiply 3 here and here, and 2 here and here. So I would get x to the 6th y cubed times x to the 6th again, y to the 8th. And then remember, when we multiply, we can add the exponents. If I write it, just write the x's next to each other. X to the 6th times x to the 6th, I can add those exponents. Y cubed times y to the 8th, I can add those exponents is the trick. So my final answer would be x to the 12th, y to the 11th. All right. Number 4, I would attack number 4 by this. I would just use the idea of it being a negative to know a negative exponent means reciprocal. So first thing I would do is I would flip this fraction or do the reciprocal, because if I use that negative sign, now it's everything's positive. I have a positive exponent, positive numbers. So I got to remember, technically there's 3 different things in here that all have an exponent of 1. So I got to multiply in and distribute that too. So I get 2 squared x squared over 5 squared. So then my final answer would be 4x squared over 25. All right. Number 5, a lot of distributing here. Let me write my little 1's in there. Technically that y is that 1, that 2 has that 1. So if I zoom in as best as I can, I got to multiply the 3 there, the 3 there. Oh, I even missed in the middle. The x to the 4th gets cubed, that gets cubed, and that gets cubed. So if I just write all that distributing, I would have 2 cubed x to the 12th, y to the 3rd, over x to the 6th, y to the negative 9th. Okay, and you'll remember that when you are dividing, the trick for the exponents down here is to subtract them. So that would give me, what, 12 minus 6 would be 6. Here's the tough one. You technically have, on the side note here, you have 3 minus negative 9. So that would actually almost be like adding. So my final answer would be then 2 cubed x to the 6th, y to the 12th. And then I can, of course, solve this 2 cubed because those are numbers. So then the final answer I'm going to write on my line here is 2 times 2 is 4 times 2 is 8, x to the 6th, y to the 12th. All right, that's page 1. Just a recap there so you can look through them. All right, on to page 2. Scientific notation begins. All right, since we have a negative exponent, that means we should move the decimal to the left. So 1, 2, 3. So the decimal goes right there. Fill in a couple zeros. So our standard number would be 0.00372 or correctly said, 372 thousandths. All right, now number one, you're making this into scientific notation. Well, remember, the rule is you have to have one number, then the decimal point. Okay, have to. So think about it. That means the decimal point needs to go right there. It has to go right there. So I know I have to have 1 point, and then I do have to include any other regular significant numbers. So now I got to think, to make this number, that means that decimal would have to go 8 to the right. So it would be 1.416 times 10 to the 8th. Number 8 is one that people get confused on quite often because of how it's written. It says write 100 as a power of 10. So we got to think literally. It's basically saying a power of 10, like 10 to the blank equals 100. And we should all know that 10 to the second equals 100 for those two zeros. Okay, notice we're starting another learning target. So here's a complete mind shift, all right? Scientific notation is done. Now we start talking about that new language we learned with cubic binomials and quintic trinomials and all of these things, okay? But first of all, when you're finding just the degree just refers to the total amount of letters in each monomial. So I notice there's 3 separate chunks. Now this chunk would be considered third degree because it's the total letters. So there's 2 x's and a y, x squared and a y, put them together, technically this y is a 1. That chunk is considered third degree, where this chunk would be considered 7th degree, and this one would be considered 2nd degree. However, when we talk degree, we only use the highest of the terms. We don't total the terms together. It's just the highest of the terms. So the answer would be this is a 7th degree. So now when you go to make the name, now we need to know how many terms there are. There's 1, 2, 3 terms. So that means it would be a trinomial. So the whole proper name would be a 7th degree trinomial. All right, number 10 is almost out of order. Again, it's just asking for the degree. Well, my friends, this is one chunk. This is one monomial. It's one thing. So all together, there's 6 letters, so it would be considered 6th degree. All right, again, notice, boom, new learning target. I gotta know I'm doing something at least a little bit different here. All right, so then it says write it in standard form. We know when you're talking about a polynomial, this is, you go from high to low in degree. So in this problem, it would be, the highest would be right there, that x to the 5th. So negative 3x to the 5th, and then yep, there's an x to the 4th. Are there any x cubed? Yep, there is just one regular x cubed. X squared, yep, positive 2, so plus 2x squared. And any regular x's, there are, yep, just 4x in the middle there. And then any regular numbers, there's just a classic plus 3. All right, now second part, leading. Think first place. The first one you see, not highest or lowest. Literally what comes first. So in this problem, it would be the negative 3. So your answer would be negative 3. Notice I didn't include the x. The coefficient is just the number in this problem. All right, number 12, add. Add. You are adding these exponents. Can't say it another time. Add. Add. This is combining like terms. If you see add or subtract, the idea is you can only combine like terms. Well, actually, in reality, these parentheses are serving no purpose because you can only add things that are like terms. So I notice here I got some x squared, so 4x squared plus 2x squared would be 6x squared. And then the only other thing I see is a regular minus 2 and a regular plus 6. So the minus 5x is what I should write next properly. and then negative 2 plus 6 would leave me with a positive 4. So all I can do is combine like terms for that quadratic trinomial. Yeah, that's it. All right, number 13, again, subtract, 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 subtract. Hey, look, there's a subtract. This is not a FOIL, none of that stuff. You can only combine like terms. But what's different is you are subtracting all of this. So the other way to think about it is that it's like you could multiply everything by a negative 1 to turn it into a plus sign in between them. So I would actually end up with negative 2p to the fourth and positive 4p to the second and then negative 3. Then over here, I didn't do anything, but the beauty of distributing that negative 1 is now nothing has parentheses. So now I can just combine like terms. 5p4 minus 2p4 would be 3p to the fourth. And then negative 3p squared plus 4p squared would be just plus 1p squared. Wouldn't have to write the 1. And then last but not least, you just have the negative 3 or just the minus 3, so it just stays like it is. Okay. Again, add or subtract. This one is supposed to be even easier because there's no parentheses at all. This is just straight up, can you combine like terms? So I noticed that these things have cubes, which is higher exponents. So I'm just going to do those first. So negative 3, take away another 6. That would be negative 9m cubed. And then positive 7 minus 2 would be 5m. That's it. That's the whole answer. Nothing else you can do there. All right, check it out. New learning target. Notice, new word, multiply. There is a multiply in between there. You are doing 2 items times 2 items, so you should get 4 items. We know that there's a special word for that. F-O-I-L. FOIL. 1, 2, 3, 4 things. Right, so 3x times 4x would give me 12x to the second. 3x times negative 3 would be negative 9x. 2 times 4x would be positive 8x. And then 2 times negative 3 would be minus or negative 6. And then we'd combine the OI, the like terms in the middle. Negative 9, positive 8 would equal out to a negative 1, or just negative x. So then my final answer would be 12x to the second minus x minus 6. All right. Again, multiply, multiply, multiply. But in this case, you have one item. This all is considered one thing, one chunk. So this one thing times this, times this, times this, right? You have 3 separate pieces, and it says multiply. So again, think about it. You have one item times 3 items. You should get 3 items. Okay, so if you want, you have the plus and the minus sign already there. You can almost think like fill in the blank. Okay, I have one thing times 3 things. I should end up with 3 things. So now it's just, can you do the multiplying? All right, so this would be 3x squared times x squared would be x to the fourth. Y cubed times y would be also y to the fourth, because technically that y is a 1. Boom, done. That's it. Then we go 3 times 4 is 12. X times x squared would be x cubed, and then there's no other y's, so it just stays y cubed. And then last but not least, 3 times negative 2, or minus 2, is minus 6. X squared, there's no other x's to combine, and y cubed times y squared would be y to the fifth. And then none of those are like terms. Let me say that again. None of those have the exact same exponents and numbers of letters and all of that stuff. So that is my final answer. I don't have to do anything. So I would just rewrite it 3x to the fourth, y to the fourth, plus 12 x cubed, y cubed, minus 6 x squared y to the fifth. All right. On number 17, my students know a perfect square technically, we cannot distribute that exponent. That would be mixing multiplying, subtraction, and exponents at the same time. I know I instantly have to write this as b minus 7 times b minus 7. Two of them, literally times itself. Well, now it's much easier to see. I have two things times two things. I should end up with a FOIL problem. Okay, so b times b squared, b times negative 7x, and then you get another negative 7x, and then last but not least, don't forget it's negative 7 times negative 7, so that would turn back into a plus 49. So then when you combine your like terms in the middle, negative 7 and another negative 7, double negative 7 would be negative 14. So your final answer is b squared minus 14x plus 49. All right. Last but not least, this thing is a beast. I'm just going to rewrite it down here. Okay, so you have two items, a binomial, times three items this time, a trinomial. So think about this. You have two things times three things. You better end up with six items down here. So I'm just going to 1, 2, 3, 4, 5, and 6. So I know I have to do kind of this double distributive. I have to do the 3x times here, the 3x times here, and the 3x times here. So I would get what? 12x cubed minus, because it's positive 3 times negative 2, minus 6x to the second, and then 3 times 5 would be plus or positive 15x. Then I also have to do the 1 times everything. Well, luckily 1 times everything is itself, so this would still be positive 4x squared, this would still be minus 2x, and this would still be positive or plus 5. So then now I can look, are there any like terms? There actually are more than one. So I notice there's regular x's, and I notice there's some x squareds going on here. So now I combine those like terms. The outside two stay the same. So my final answer would be 12x cubed minus 2x squared plus 13x plus 5. All right, there it is. Good luck. Please let us know if you have any questions. I'll answer panic questions tomorrow. And have a good day. Do your targeted review. And thank you for watching. Have a good day.